Here's another thing you'll see in stoichiometry problems. You have already learned how to do many conversions, so not every problem has to always start off with either grams or moles. Here is a balanced chemical reaction where the first reactant, ethanol, C2H5OH, is a liquid, so we measure out the milliliters of that reactant. The other reactant we measured in grams. We are told that we make 3.1 milliliters of water as the product, and from that we want to figure out what is the percent yield. So we're given some conversion factors with the densities. The ethanol and the water are both liquids, and in the lab it's easier usually to measure the volume rather than the mass. So we need the conversion factor of density to turn our volume into mass. So this problem is going to involve a few more steps than a standard stoichiometry problem, but the technique is the same. To find the percent yield, we need to know the theoretical yield, and we want to figure out how many grams of the product water could come from the starting amount, 3.8 milliliters of ethanol. Remember, stoichiometry works when you get everything in terms of moles. In this case, we need to turn our milliliters first into grams using the density as a conversion, and then we turn our grams into moles using the molar mass. So milliliters into grams, the density 0.789 grams is 1 milliliter. So that's one extra conversion step, but then once we have grams of ethanol, we can turn that into moles of ethanol using the molar mass, and the molar mass is 46.07 grams per mole. And now the rest of the problem is pretty similar to what we've seen in the past. Use the mole to mole ratio from the balance equation. 1 mole of ethanol produces 3 moles of water. And then use our molar mass of water. 1 mole of water, 18.02 grams. And this will multiply out to 3.52 grams of water if all 3.8 milliliters of ethanol react. We have a second reactant. This time we're starting with grams, so we don't need the density to get our grams into moles. We are going to set our unknown, how many grams of water, equal to the known 12.5 grams of oxygen. Grams of oxygen, we need moles of oxygen, and the molar mass is 32 grams per mole. Then we need the mole to mole ratio. In this case it's a 3:3 ratio. Three moles of oxygen produce 3 moles of water. And then our molar mass, we just saw water, 18.02 grams per mole. So this is going to give us 7.04 grams. So same technique, smallest number is our theoretical yield. The chemical that produced that, in this case it's the ethanol, must be the limiting reactant. The other reactant is excess, in this case the oxygen. And then finally, to figure out the percent yield, we were given the actual yield in terms of milliliters. Well, our theoretical yield is in grams, So we just need to convert the actual yield of 3.1 milliliters of water into grams using the density, and the density is a nice 1 gram per milliliter. So 3.1 milliliters is just 3.1 grams of water. That's the actual that was given in the problem. So to find the percent yield, we put the actual on the top, divide that by the theoretical, which is 3.52, multiply by 100, and we get 88.1% yield.